I'm joined by Dan Solak from Thomson Reuters, Gareth Smith from Progress Apama, and Fahim Rahim from Rapid Addition. And we've been working together on applying this with other partners as well to financial services. Now, you know that Intel has been positioning in the faster, low latency space, those you're familiar with financial services. If you're targeting performance in financial services, you look at what we call the wholesale sell side and the front office space. So we've been doing a lot of work with a number of software houses in the trading life cycle around market data from the likes of markets exchanges through into the front office brokerage firms and then back out for execution on the marketplace. So I'm going to hand over to my colleagues in a minute, but before I do that, I want to run a very short video which will show this actually in action. Again, before I switch the go button on the video though, if you can imagine a stock exchange being somewhere over there where the control console is, the data comes into Dan, right, market data area there, into the feed handlers. It again gets passed to Gareth, who does some maths on it and calculations, and he is from Cambridge University, so he should know how to do that. And then on to Fahim to pass that data out to the exchange again to do the trade. So the demo that we're going to show you in actual fact is the data being sent effectively from Gareth to Fahim and then out to the exchange. Now, for those of you familiar with latency and throughput, low latency is good and high throughput is good. So some numbers have got to be lower and some have got to be bigger. And what we're going to do is show a race between Harpertown and the Halem Xeon 5500 series. And this is quite staggering when you see that this technology we're comparing is only 9 months old anyway, compared with the new architecture. So let's run the demonstration, please. So top row we've got Halem. Bottom row we've got Harpertown. Look at the green buttons here for Halem. That's latency for the outbound message to the exchange and latency for the inbound message coming back. And on this side we're seeing throughput in terms of volume of messages. Overall we're seeing about 14 microsecond latency with Halem compared to 21 from Harpertown, and in terms of volume of messages going through, 69,000 from Halem compared with 46,000 for Harpertown. So let's put that into context. If it's lower latency, it means we're getting to the exchange faster. If it's higher throughput, it means we're putting more trades and executing more profitable orders that much quicker on Mark Stock Exchange. So, really quite phenomenal. So if we go back to my slide now with the panel, what I'd like to do now is actually go very quickly through the three colleagues, Dan, Gareth and Fahim, to give us a little bit more flavour as to how they've applied Xeon 5500 series in the labs. We've been working at engineering level to make this work. Some fantastic results, but even more from tuning. So again, remembering Dan is up at the market data coming into the firm end. Give us a little bit of flavour, please, Dan.
Thank you, Nigel. Current volatility and market conditions is actually driving market into electronic trading, and a boom into algorithmic trading is creating perfect storm with the data updates and volumes. To deal with those, you have to have infrastructure and capabilities to accept it and pass it through your infrastructure before it goes to other applications to be calculated, prepared and passed through. So from us at Thomson Reuters, we have a market data system that is fully capable to take the data feeds from multiple exchanges and other sources and prepare the data, stabilize it and pass it down to other applications. Through our work, and actually our engineers' work at Thomson Reuters at Intel in cooperation, we have managed to re-engineer our platform to completely re-architect it and leverage the benefits of Intel Xeon 5500 series processor, together with applying multi-threading on top of it to obtain an enormous level of performance comparing to previous versions. What I'm talking about is actually we achieved 8 times performance improvements. Now that is really an enormous number of improvement levels. And I'm talking about reduced latency and drastically increased throughput through our platform, which will definitely drive markets to reduce the footprint, reduce cost, power utilization, as well as reduce expenditure on heating.
Great. Good. Thank you very much indeed. So passing that piece of data that Dan's brought in from the exchange to Gareth, who does some maths to create some trades.
Okay, thank you. Good morning, everybody. This is the most attractive piece of market data I think I've seen. So Apama is an event processing platform. It's a high-performance event processing platform. In the capital markets arena, we receive massive amounts of data from down on my right here, and then we run analytics and applications across that. And so the sorts of applications we run are things like trading applications. We also do things like real-time risk compliance. There's a whole range of a whole spectrum of different types of applications. And we've been working with Intel for some time now. I think adding the number of threads and the capabilities that's been happening at the hardware and the software level is a non-trivial exercise. And our engineering teams have been more than impressed with the new hardware technology coming out of Intel. And across all our applications, we gain an order of magnitude of about twice the performance. So that's across all our real-time risk firewalls, across all the trading applications we have. And so what allows you to do essentially is run your applications more intelligently. It gives you more horsepower to write additional smarts into your applications to be a little bit more intelligent, to cover more of the market, to increase things like, for example, having an order firewall sitting in between your orders to make sure that you have a tighter grip of what's going out there. And do that without increasing your latency, in fact reducing your latency even with additional power and having the extra throughput. So it's very beneficial for us to have that.
And Mark mentioned smart order routing. You've also got smart order routing, so new regulations like MiFID, you can actually seek out the different execution.
Correct, and so the view of having all your computing power just go to do the application you want to run, now with the compliance around the side of that, with this new hardware and with our latest platform, you have the ability to run everything you need to run without compromising any of your performance. And what's critical from our point of view, as well as the actual underlying performance, is the ease of use. We don't essentially, and this is what Intel provided too, is you don't provide, here's the new hardware, and then here's 1,000 knobs and dials you need to tune to get anything out of it. No, it just, here it is, and we've applied our platform to fit to it, and it just runs. And so we're affording that performance improvement to our users just with a straightforward ease of use.
Thank you. So the trades that you generate with Dan's data go to Fahim. Using industry standard messaging, you then route that to the exchanges to Mark.
Yep. Good morning. Just to reiterate the point, we'll pick up the messages from applications such as Apama's or the LSE's trading system, and what we'll do is we'll process the messages using our fix engine, using industry standard FRIX protocol messaging. Now, the interesting point, and what you saw from the demonstration before, is we actually see a leap in 51% performance in throughput and a reduction in 33% latency. So we're jumping from 46,000 messages per second to 69 plus K messages per second in parsing and making available to the business logic side of the application. And what that's giving us is, or what that gives our customers, is the edge in being able to send out trades a lot faster, a lot quicker, get responses, and hence the smart order routing pieces and the LSE's applications. They're able to get these trades a lot quicker than they could against Harpertown.
Good. Okay, so I think what I hope we've demonstrated here is that we've just taken a little subset of the relay race that is financial trading. Market data from an exchange or venue coming through, pass through the firm and out. And what we're doing here is positioning the technology, investing with our partners so that they're all, as Tom said, ready for market at the point we bring this product out, which in my career is pretty unique in terms of level of readiness. So in addition to our three friends here, there are a number of other vertical financial service ISVs who are tuned on the Halem 5500 series, ready to come to market, all with stunning performance figures. So when a firm is looking to update and upgrade in any particular area, then we can point them to the software houses with that capability. And of course, financial trading being a relay race, as I say, if you have one point of least resistance, then the whole cycle slows down. So we do expect to see quite a significant interest in this technology in the market. And as Tom and Mark implied, lower energy costs equals return on investment. Here, it's fundamental profitability in terms of hitting venues with more trading opportunities.